Good evening, all. It's a great honor to be invited to give this lecture. It's my pleasure to meet you all this evening and discuss few topics related to financial technologies. Let me share my screen. Uh, can you see the screen?
Yep, we can see that.
Yeah, just a moment. Okay, great. While I discuss topics related to financial technologies, I try to water down most of the rigor so that you all could understand the underlying basic concepts without having any difficulty. So let us start with a simple question. What is FinTech? Well, the simple answer to this question is FinTech is nothing but finance and technology. But don't misunderstand that this is something like water and fire. In fact, finance and technology are not separated, they are tightly integrated. A more sensible, precise answer to this question is FinTech is nothing but finance delivered by technology. I believe all of you have seen some FinTech applications in real life, and it is not a big issue to understand some of the important characteristics or features of financial technology solutions. The first and foremost feature that we all would recognize is that finance need to be delivered in real time. So that means it is a sort of immediacy. If I want it now, please let me get it now. As simple as that. And the second important feature that we all could sense is that finance must be delivered to everyone, everywhere, all the time. So that means it is a sort of democratizing the finance by using the existing technologies, by applying them in finance. And due to the current state of web technologies and internet technologies, this is a reality at the moment in financial world. The first two features could be easily be considered as a reality at the moment. And the third important feature of FinTech is seamlessness. So that means effortless. We should not think about finance and banking and breaking our heads on daily basis. So the finance and banking must be properly stitched into the fabric of our lifestyles so that actually we could comfortably ignore banking and finance activities unless until we need to pay our attention on any particular thing in finance and banking related activities of our lives. And the fourth important feature for FinTech solutions could be personalization and predictiveness. So there is no point in providing financial services and products, uniform financial services and products to everybody in this universe. So there must be a degree of personalization. Customization is the key for success in FinTech world. Up to some extent, we must be in a position to forecast the finance. So that means if we are in a position to foresee what is going to happen, we might be in a position to eliminate or reduce some of the risks that are involved in our decisions related to financial investments, for example. So the last two features, that is seamlessness and personalization and predictiveness, are very much possible with the advanced data science techniques like machine learning and artificial intelligence. So we'll go through those things mainly in this lecture. So far, so good. We understand what we mean by FinTech. But the next level fundamental question is, what is finance? Finance is nothing but money management. Then obviously it turns out to be asking the most basic question, that is, what is money? So in order to understand money, we need to travel in time, start our discussion with the Barter Society. Thousands of years back, there was no money, but still people used to exchange goods and services they used to produce in any given society. The only constraint to survive in Barter Society is we need some sort of double coincidence of wants. That is what we say in economics. What we mean by double coincidence of wants. For example, person A has apples and he wants chicken. Person B has chicken and he wants apples. That is what we mean by double coincidence of wants. And they can comfortably exchange the goods and close the deal. But the issue is when the society is going to produce more and more goods and services, it is not trivial to match the buyers and sellers, because when you have enormous amount of goods and services, it is almost impossible to satisfy the constraint that is double coincidence of wants. For any given pair of products, it's almost impossible to find buyers and sellers. So at this stage, people realized that it would be a good idea to consider an intermediate good or intermediate service, so that actually we could exchange the other goods that we are going to produce by using the intermediate good. The intermediate good could be anything, for example, grain, pebble, or precious metal. And this intermediate commodity is named as money. Over a period of time, people got enlightenment further, and they understand that, oh, money is just convention, nothing else. In fact, anything could be considered as money as long as people put their confidence on it and accept it for the purpose of exchanging the goods. And from then onwards, people started accepting pieces of metal, pieces of paper, pieces of plastic, and bunch of electronic digits as a sort of money. And the required confidence that is needed for these pieces of paper, metal, plastic, and bunch of electronic digits, provided by the financial authorities of the country, usually the central banks of the country. In any society, at any point of time, there are savers who have excess amount of money after fulfilling the needs, and there are borrowers who are willing to borrow money in order to fulfill their immediate ambitions. Perhaps savers might be interested in lending their money to the borrowers with the hope to get some excess returns in the form of interest. As you all know, any idiot can lend money, but only few people can get back the money that they have lent. So that means there exists certain degree of risk in the process of lending and borrowing. So we need somebody who could take care about the underlying risk. And we need intermediaries who are going to take the risk and eliminate it in the process of lending and borrowing. And those intermediaries are known as banks. As you all know, banks would lend money at high rate to the borrowers and pay less interest to the depositors. So the profit that they are going to get is a sort of payoff for the risk that they are going to eliminate. The important point that you should notice at this stage is when you just look at the financial world, there are always intermediaries. That could be central banks, that could be banks, or any other financial organizations that are willing to control or influence the money management process people would like to perform in their lives in any given society, in any given network. But if you just look at the other cases, in the early barter society, not much role for the intermediaries. If you know a bit of Bitcoins related to cryptocurrencies, you don't find any sort of centralization that could control the sort of money management process people would like to perform. The biggest contribution, one of the biggest contributions of FinTech to the society is eliminating the intermediaries, or at least reducing the intermediaries up to some extent. The other important contribution of FinTech to the society is improving the financial inclusion. What do we mean by financial inclusion? With financial inclusion, more people, more businesses can get access to the financial services and products that they are willing to, or that they are affordable in their lives. So when you just look at any of the old legacy systems. For example, by the way, the basic form of financial inclusion would provide us with the opportunity to store money, transfer money from one point to the other point, lend or borrow money whenever we need. If you just look at the old legacy systems and would like to send money from one geographical location to the other geographical location, then you're supposed to pass through many intermediaries, and each and every intermediary would take a cut so that actually the underlying transaction costs would be so huge. And examples of fintech solutions, perhaps you all are aware of, would eliminate some of the intermediaries and speed up the process by reducing the cost. We have already discussed intermediary role in the process of lending and borrowing. If you just look at the intermediaries in this case, what exactly the intermediary is doing is try to minimize or eliminate the underlying risk. What do we mean by risk management? It's all about number crunching. When we have access to big data in finance, and when we have access to the big data technologies, we can always replace these intermediaries by using systems, by using some platforms, automated platforms using artificial intelligence, machine learning, and other big data technologies, so that actually many of the intermediaries in this aspect also could be eliminated. And some of the fintech solutions in this area are known as P2P lending and crowdfunding. Hold a moment. Finance has many facets. We just discussed about few facets. The facets that we so far discussed are storing the money, transferring the money, lending and borrowing. These are just few facets of finance. As I mentioned, finance has many facets. So that means it has many topics. What so far we have done is we just barely scratching the surface of fintech. So we could use the advanced technologies in many finance topics so that actually we can bring more scientific approach to the finance. That is what actually I am going to do. I'm going to explain in the next few minutes of this lecture. I'm going to concentrate on other interesting topics in finance where we can bring technology. Technology, I mean big data analysis, artificial intelligence, machine learning, you just name it. Web technologies, blockchain technologies, all these technologies could be used in many topics in finance. The topics that we are going to consider for this lecture are risk management, big data in finance, algorithmic trading, high frequency finance. While we are discussing these topics, I take few examples and explain in detail, intuitively, so that you could sense where exactly we can use these technologies in finance. As we all know, digitalization of finance is flourishing on the foundations of cutting edge technologies. All these topics are basically depending on few technologies like data science, econometrics, big data technologies, complexity theory. It's all about using various combinations of these technologies in order to bring more scientific approach to finance. As I mentioned, I concentrate on few examples for the sake of explanation, how one can understand, improve the stability of banking system using the technologies, how one can improve the performance of algorithmic trading by using scale invariance techniques rather than usual time series analysis, how one can continuously monitor the health of the financial markets so that we could avoid any sort of crashes in the market. So these are the things that we are going to consider. Let me explain a few simple things that you are supposed to be aware of when you are studying finance and applications of technology in finance. Most of the times, banking and finance is considered as sort of observational science. That means we passively observe the available data and try to understand the underlying data generating process in order to hypothesize and explain the underlying phenomena that is causing the data generation. But in the context of big data in finance, it is not that trivial to come up with the mathematical models that could explain the data generating process across all granularities of the data. You have data at low frequency, data at high frequency. Is there any model actually that could explain the underlying data generating process across all the frequencies? That is an issue. And we try to answer that by discussing and talking about scale invariance techniques. One can combine complexity theory and artificial intelligence combined with the available big data in finance. We can bring more scientific approach to the finance, and we can make finance as a sort of experimental science. We should understand the subtle difference between observational science and experimental science. Let me take a very simple example and explain the differences between experimental science and observational science. For example, we are interested in understanding the relation between the height from where apple is falling and the velocity that is going to reach before hitting the ground. In observational science, what we do is we just go out into the garden and passively observe apples falling from the trees and note down the data. Whereas in the context of experimental science, we set up an experiment in the laboratory by just dropping a bunch of apples from different heights. So this is the crucial difference between observational science and the experimental science. Why do we need the experimental approach to banking and finance? The moment we have access to this experimental approach, we will be in a position to get the required reciprocal feedback between the data generation and the theory that we are going to develop based on the available data. This reciprocal feedback is the crucial thing. Having understand these basic things, let us move on to some of the technical applications one could consider in finance. As we all know, financial markets are producing enormous amount of data, and studying the financial markets is nothing but big data analytics. Usually what we do is we try to identify the patterns in the given data, and after identifying the patterns, we try to mathematize the patterns. Here, after identifying the upward trend in the given data set, what we usually do is we try to estimate the linear relation between the variables by considering some regression analysis. But the issue is the patterns that you see at high frequency may not be available at low frequency. For example, the patterns that you find in daily data may not be available in monthly data. The patterns that you find in daily data may not be available in minute by minute data. When you talk about high frequency finance, then you are supposed to understand the tick by tick data. What we mean by trying to do here is asking ourselves the fundamental question: are there any patterns that are consistent across all granularities of the data? Or the other way of asking the same question is there any model, mathematical model, that could explain the data generating process consistently across all granularities of the data? This GIF would explain you what exactly we are trying to achieve. Whether we zoom in or zoom out, we are supposed to find the very much similar patterns. That is what we mean by scale invariant patterns. Why should we find such type of scale invariant patterns? Then, once you identify scale invariant patterns, that particular mathematical model would be good enough to understand the data across all granularities of the data. A simple example, a simple mathematical way to describe the scale invariance patterns is y equals to alpha times x power b. You could easily verify whether this is following the scale invariant pattern or not by just changing the x value and look at how y is changing. And this might be a good homework problem if you want. So the question is how to find the scale invariant patterns in any given big data. So there are actually different approaches. We need special looking glasses in order to detect the scale invariant patterns. Before going into that particular technique, let us see how we usually summarize the data in traditional time series analysis. When you are considering the time series, we try to take snapshots at regular intervals. And after taking these snapshots at regular intervals, we ignore the other observations that were not presented at the time of snapshot and summarize the data. So what we do is, after taking the snapshots, we extract this part of the graph, and this is considered as the summarization of the original time series. What are the issues with this one? The issue with this one is you would miss some of the crucial observations that you're supposed to consider for your data analysis in order to get best results in your financial analysis. One could argue that we could eliminate such type of missing observations by increasing the frequency of the, the snapshot. So that means the moment you reduce the interval length, perhaps you might capture most of the observations. But the issue is, if you increase the frequency of your observation, you are increasing more noise than the signal to the model that you're going to consider. So for that, what we usually do is we try to monitor the given financial market according to the event time. That means we try to observe the markets according to the body clock of the market, but not the physical clock of the world. So for that, we need to define what we mean by an event. Event could be anything according to the user. User could define any event, but the most sensible way to define an event in financial market is going to be certain percentage of price change. So let us say 1% price change is a sort of an event to me. For somebody else, 2% price change could be an event. So that is up to the user. So once we define the event, we try to monitor we try to summarize the markets according to the event time. What we do is, for the sake of example, let us say that event is nothing but 5% change in the market price. What we do is we try to find the extreme points from where price is dropped by 5% or rose by 5%. If price is dropped by 5%, we would say that downward directional change event happened. If the price is rose by 5% up, we say that upward directional change event occurred. From the beginning of the first directional change event to the next directional change event is known as overshoot event. So basically, we consider this upward, downward, and overshoot events summarize the data. It would be so simple to summarize the data. At the same time, you are not missing any observations because you have defined the event. Here, if you just repeat this exercise, then what happens is we are in a position to summarize the given big data according to the event time that we consider. And you can see that we are summarizing the data as upward, downward, nothing else. So what are the advantages? The advantages are plenty, but before going into those details, just have a look at these two approaches. In physical time approach, in regular time series analysis, you take the fixed intervals. Whereas in the intrinsic time or event time approach, you take irregular sort of intervals. So why? Because you're following the body clock of the stock market, so that actually you're in a position to understand the situation in a better manner. So what are the advantages? The advantages are plenty. You could mathematize many scale invariant patterns. For example, if you would like to mathematize any sort of scale invariant patterns and represent them as power law, as we discussed a few minutes back, all you need to do is you just take the logarithm of the variables and try to fit the regression analysis for those logs. In that process, actually, you would identify dozens of scale invariant patterns in foreign exchange market, commodity market, equity market. What is the advantage? The moment you understand the scale invariant pattern, you could use that pattern so confidently across all frequencies of the data, because that is there across all frequencies of the data. The risk management would be excellent and the portfolio management would be be excellent. So the next big thing that we need to do in the other aspects of finance is basically how to automate the portfolio management, how to automate the risk management, how to manage the risk by using the machine related sort of techniques. Obviously, in order to perform these computations, you need to do a lot of number crunching. It involves crunching terabytes of data because you are handling the very high frequency tick by tick data in order to understand these patterns. For that, actually, we are going to use, or we usually use, big data technologies like Hadoop platform and Apache Spark computing engines, so that actually you will be much ahead of the rest of the crowd. So your risk management would be far better than the rest of the crowd in the market. This is one aspect, and there are some examples here. What are the scaling laws that you could find? Here, I am just going to show you a couple of scaling laws. What it says is, the moment you say what percentage is considered as an event, and you would clearly see the relation between the overshoot event and that magnitude of the event. So more or less, they are almost equal most of the time in the market. And how long it would take for overshoot to end in any given market is basically explained in this particular power law. And as I mentioned, actually, when you have the scale invariant techniques in your bag, you can monitor the given financial market across all time scales. So that means you could be in a position to diversify your risk across all granularities of the data. So that would be another advantage with this kind of big data analysis in financial markets. The next topic that I would like to discuss is the combination of complexity theory and data science in financial markets, or in general in finance. Without worrying about the precise details of the complexity definition, let us assume that a system is complex if it has a large set of interacting components with no central control that could exhibit some sort of emerging global behavior. Do not worry about the long definition. If you just look at the school of fish, that is nothing but a complex system. Why should we define that as a complex system? It has a large number of interacting components. Millions of fish are basically part of the given system. There is no central control. There is no kingfish here. So there is no central control. Even though we understand the local interactions of the individual fish in the given system, it is not that trivial to understand the global pattern they're going to display, because of the local interactions. So obviously, this could be considered under the definition of complex system. Similarly, bird flocking is also considered as complex system. But we are not interested in such type of systems. What we are interested in stock market. The stock market is a complex system because it has a large number of interacting agents or interacting elements, millions of traders participating in the market and interacting with the market with their own trading strategies. And in that process, they are in a position to create some sort of global patterns. You may wonder actually what sort of global patterns these guys are producing because of these local interactions like fish or flock of birds. The patterns that they are creating co-creating from the local interactions are nothing but price time series. Price and volume could be considered as a pattern these people are going to create. And the now question is basically, is there any way that actually we could study the complex systems? Studying the complex system is nothing but understanding the unfolding of the global patterns due to the local interactions. We could actually model such type of complex systems by using different techniques from machine learning and simulation. For example, one can model a stock market using agent-based models, for example. Agent-based model is a simulation technique where we create artificial stock market and populate the artificial stock market by creating artificial traders, where each and every trader has a set of trading strategies, where each and every trading strategy is nothing but the trader's hypothesis about the expected future value. From time to time, these artificial trading agents would interact within the market. In that process, as we discussed, they try to create some global patterns. So by using this, sort of experimental technique, you could create an artificial market and continuously monitor. And it is our hope that the patterns created by the artificial market would match with the real market. In this case, the real market could be S&P 500. Why do we call that as black box? Because we do not know anything about the internal composition of the market. It is almost impossible to understand the internal composition of the market. All we know is basically the patterns the real market is going to create. But what we have done is we created a laboratory experiment by creating artificial market on our computers using data science techniques, machine learning, whatever it may be, the advanced computing techniques. And we are in a position to create an artificial market that would look like the real market. What are the advantages? The moment you have the market in your hands, you can continuously monitor, you can continuously foresee the underlying risks that you're going to see in the near future. But there is one issue here. We really do not know how to create the best agent-based model or the exact composition of the artificial market that could behave exactly like the real stock market. Here, you can actually use some machine learning techniques. Before going into that, we can use these things to understand what is the likelihood of the next crash, what is the likelihood of next flash crash in the next few minutes or few hours. All sort of questions could be experimentally verified. So now let us go back to how to create the best agent-based model that would behave exactly like our stock market. So for that, we are going to use some machine learning techniques, especially evolutionary computing techniques in like genetic algorithms or genetic programming. What we do is we just try to look at all possible agent-based models, candidate agent-based models, and we just convert them into binary strings and perform the traditional steps of the genetic algorithm. Do not worry if you are not aware of the genetic algorithms or genetic programming. You just imagine that there is a black box that would find the best agent-based model for me. Once you get the best agent-based model, remember that you encoded that into string and you need to decode it. The moment you decode it, you get the artificial agent-based model that is a good fit to the real market. All you need to do is run the computing on your computer and see how the artificial market is creating the patterns. You can clearly see that the artificial market that we have created here is more or less matching with the real market. Up to some extent, for example, if you just look at this graph, up to here, this part of the data is in sample and the other part is the out of sample. Even out of sample is also reasonably good. So that means we must be in a position to understand the exact composition, microstructure of the real markets so that actually you could do wonders with this kind of, approaches by combining data science techniques, machine learning, and big data in finance. I just close by talking about one more important application that you could perform. Is the understanding the stability of the financial system. When you have actually hundreds of banks interacting with each other, if something goes wrong with one of the banks, then that bank might influence, because all these banks are interconnected, and if bank J fails due to the connectivity with the bank I, then there is certain degree of risk for bank I to get failed. So all these things can be comfortably model by using the complexity network approach, and try to monitor whether there is any sort of underlying risk with this sort of banking system on it. For example, if something goes wrong with one bank, if that is going to influence and going to sort of smash the other banks as well. For example, if you just look at this scenario, there is a problem and one bank is collapsed, but that is propagated to only the other three banks in the system, but the remaining banks are stable. So this kind of contagion process is known as convergent contagion process. So that means this won't propagate that far, it would stop some point. But if the system is not so stable, then what happens is if something starts at one point in the network, the entire network would be collapsed. So we can continuously monitor by using the advanced data science techniques, and we can see whether the banking world is performing well or not. So these are the some of the topics I would like to share. And the other interesting applications, obviously, technologies are blockchains, social science networks, social networks, big data analytics, artificial intelligence from technology's point of view. And the processes that we could automate using these technologies are lending, borrowing, investments, payments, financial advice. And there are many players, new startup fintech companies, and the existing legacy institutions, banks, financial organizations. If you ask yourself what would be the future of fintech, the precise future of fintech is going to depend on how these three individual components are going to interact with each other. We cannot predict the precise path of future of finance, but what we can guarantee is information asymmetry in the financial world will be removed. Role of intermediaries will be reduced. For everybody, smart advice is available using artificial intelligence and machine learning. Markets are frictionless, and markets would always display the true prices, fair prices for everybody. And you always be guaranteed with stable financial system. And on the top of that, we could bring more scientific approach to the world of finance. And I would stop here, and I'm happy to take if you have any questions.
Yes, thank you, Dr. Raju. And so for those of you who are here listening to the session, if you have any questions, please post it into the chat function, and then we will pick up the question from there and Dr. Raju will answer. If there's no further question regarding the topic, Dr. Raju, shall we move on to the program info session? And along the way, when you have any questions, just type it on in the chat, and we will take it from there. Okay. Yeah. So you have to share the screen.
Yeah. Can you see my screen?
No, you.
Did I?
No, it was still the old slides. Perhaps you can stop sharing first and then reshare again. Yeah.
Just a moment.
Yeah. So still the same thing. And if you have any question, for those of you who just joined, please put your question down on the chat, and then we will pick it up later, and Dr. Raju will answer these questions.
Just a moment.
Sure.
Okay. Can you see?
Not yet.
Yeah, I'm there.
Okay, there you go. Yeah. Yes.
Just sorry for the delay. Okay, let us go back to the details of the program. MSc Data Science. Thanks for your time this evening. This is a sort of a bit extension to the discussion that I made for the last 30, 40 minutes. My discussion, my previous discussion was very much centered around data science. So that's why I didn't bring some of the other important topics of financial technologies like blockchain and the other things. What happens is when you have blockchain technologies kind of discussion, that would itself is a sort of big topic, and we have a bit of less room for discussing the data science. So that's why. Okay, let us look at the data science. As we all know, data is new oil. That's what actually we all believe. And whatever it may be the domain of interest, data or the number crunching is the most crucial thing, because the businesses, irrespective of the domain, they are basically moving towards the digitalization. So each and every business is basically thinking of digitalizing their business or their services. And if there is any sort of one profession that is applicable to all the domains, that is data science. Data science expert could be in banking and finance. They could be in economics. They could be in engineering. They could be in medicine. You just name it. So this would be a sort of a lucrative profession, at least for the next 1.5 decades, because most of the businesses are basically trying to digitalize their businesses. What we learn in MSc Data Science is the following. You get the strong foundation on basic concepts like maths and stats, programming, at least in one programming language. So one programming paradigm you should learn. And you should also know the building blocks of data science like artificial intelligence, machine learning. In addition to that, you should also know the technologies that you're supposed to use in the context of big data. So these are basically considered as core topics. So let me go through that one by one. As I mentioned, uh, data science is a fast changing area. The skills and knowledge you would get, you're supposed to continuously evolve. But as long as you have the strong foundations, it would be relatively easy for you to, transfer your skills to the next technologies that are available. So the master's program consists of 180 credits. It takes 2 years to complete. And postgraduate diploma, 120 credits. And postgraduate certificate involves fulfilling 60 credits. And the subjects that you are going to learn are the following: 4 core modules, as I mentioned before: mathematics and statistics for data science. For example, you must be aware of some of the techniques from statistics, for example, bit of probability, bit of calculus, bit of linear algebra. And you must be aware of certain machine learning techniques, neural networks, and some of the other artificial intelligence techniques, so that actually your foundations would be strong. Whatever it may be, the advancements you could easily adopt on your own once you have finished the MSc Data Science. As I mentioned, you should also have a bit of knowledge to be successful, a bit of programming knowledge, but that is not a sort of prerequisite. You will learn when you are doing these modules. And of course, big data techniques or analysis are the 4 important core modules. And you have compulsory modules like data science research topics. You just pick up a research topic of your interest and you just start working on that. Data visualization is an important area, because most of the times, most of the people are not aware of what exactly the data scientists are doing on the big data. For most of them, that is just a black box. So in order to give a lot of confidence to your clients as a data scientist, all you need to do is you must be in a position to display the results in a sort of more sensible manner, so that actually your clients would be very comfortable and rely on the solutions that you are going to provide. If you don't show anything to your clients who are not aware of the existence of the techniques and tools that you are using in big data, then that would be a tricky thing. So data visualization is another important thing. So these are basically the core modules when you consider the data science, and the remaining modules are basically optional, depends on which stream that you're going to choose in your MSc data science. Are you going to take MSc data science on FinTech? If that is the case, you can see that there is one small change to the 4 core modules, that is basically inclusion of financial data modeling. So as we say, data is oil, even that is oil for even banking and finance as well. So you must be aware of all the sort of basic data modeling techniques, including time series analysis and the other econometric techniques. You must be aware of all those things will be taught to you, so that your foundations will be strong enough to be successful data scientist. And in the 3 compulsory modules, you could see that a couple of extra things, that is mathematics of financial markets and blockchain programming. Blockchain programming is very important because in financial world, the most interesting thing is transferring value from one place to the other place in the given network with confidence. So that confidence could be achieved by using the blockchain technologies. And that is also a very important thing in the context of FinTech. And you must be aware of mathematics of financial markets, like derivatives, options, other stochastic, sort of calculus related models, which are very important to understand and model the financial markets. And 3 optional modules of your choice. So you may go towards neural networks, artificial intelligence, or any other topics that are more relevant to your interests. When it comes to the artificial intelligence, so you could see that actually some of the FinTech core modules are basically replaced with artificial intelligence and neural networks. So that all depends on your interests and future ambitions. So when it comes to the program structure, the next intake is October 2020, in a few months' time. And we run each semester 22 weeks. So if there are 10 topics per module, you have roughly around 2 weeks time to finish the module, going through the video lectures, reading material, doing the quizzes, practicing some problems or practicing some programming, depends on the subject that you're going to consider. And here are some of the dates where regarding the exam and courseworks and the other stuff. And mode of delivery depends on the choice. So you would certainly be provided with the video lectures and the reading material and the programming tools and the computing engines. For example, if you would like to do big data analysis, so you don't need a supercomputer on your own, so you can always log on to the cluster computer that we are going to provide at University of London, where you can do the number crunching using terabytes of data, which is very exciting, not only for your courseworks, but your sort of project that you would like to take up as part of your program. So there are certain entry requirements. If you have first degree in relevant subject, that is, the relevant subjects are given. Obviously, these are a bit inclined towards STEM subjects: science, technology, engineering, mathematics, any sort of number crunching subjects. So that is entry route 1, and the minimum requirement is second class. For entry route 2, even though you do not have degree in those mentioned subjects, you could take some 1 or 2 preparatory courses and clear those courses, so that actually we believe that we are in a position to grasp the topics that we are going to discuss uh, in MSc Data Science. Yeah, so we look forward to hearing from you, and if you have any questions, we're happy to answer at this stage.